I have your attention, please? We are now approaching Burbank, and the captain estimates we will be on the ground in 5 minutes. Please observe the no smoking, fasten seatbelt light. Thank you.
This is an era of turbine-age flight, tailored to give sky comfort rides along the busy air lanes of the world. To meet the demands of speed and scheduled reliability, you need dependable equipment capable of providing consistent service on your expanding routes, with safety, versatility, and economy of operation. Economy, made possible by use of this prop jet transport, designed for maximum utilization within our system of world airports today.
Boy, that Electra really stops short every time. That's less than 1,000 feet of runway.
Announces the on-time arrival of Electra Flight 203 from Logan.
On-time arrivals, a goal and a standard with the Electra, Lockheed's unique answer to the world's airline need for a practical transport, whose every feature is carefully integrated to provide profitable operation on the bulk of airline routes today. Built-in power-operated stairs, weighing less than 100 pounds, respond quickly to their cabin or ground control to expedite passenger handling. No waiting, no delay with these carry-on luggage racks, capable of accommodating full-size two-suiters with ease. Time-saving techniques were a major consideration in the design of maintenance features in particular, and we'd like to acquaint you with some of them during servicing operations at this terminal stop. Fast ground servicing and a minimum of maintenance delays were key objectives in shaping the Electra pattern for profit. This design represents the combined thinking of American and Eastern Airlines working with Lockheed engineers and their maintenance specialists to achieve one of the highest degrees of maintainability ever built into a transport. Such maximum maintainability is the result of strict adherence to the basic design principles of simplicity, reliability, safety, interchangeability, accessibility, and serviceability. With these prime requisites guiding the Electra designers, servicing operations were planned to require but 12 minutes at en route stops and 20 minutes at terminal stations. Such rapid turnarounds increase the block speed advantages and daily utilization of Electra flight. Most of the servicing functions are restricted to the right side, allowing multiple operations to be accomplished simultaneously without interference or clutter, leaving the left side clear for passenger traffic. Cargo doors, 52 inches wide and 42 inches high, among the largest in the industry, open inwardly and slide out of the way, reducing any possibility of damage. Ground crews appreciate these larger, well-lighted compartments with sills so low that little or no special equipment is needed for easy access. Turbine engines use JP4 or kerosene-type jet fuel. The Electra uses either, or if necessary, they can be mixed without the need for any fuel control adjustment. Refueling operations are simplified considerably by use of an underwing single-point adapter located at the rear of the number 3 engine nacelle. This single-point system cuts the conventional overwing fueling time in half or better. By means of this central fueling point, all 4 tanks, 2 in each wing, can be filled simultaneously through a single manifold. This control panel incorporates quantity indicators and various control and check switches to ensure safe operation of the refueling procedure, which transfers fuel at the rate of 420 gallons per minute at 35 psi. With this rapid rate, refueling the Electra after a 1,000-mile flight will require but 4 to 5 minutes. Refueling after short hauls will not be necessary. All 4 tanks, when empty, can be refilled in approximately 12 minutes. In addition to reducing fueling time, this underwing system eliminates the hazard of slipping on the wing, especially during wet weather, and it also eliminates any possible damage to upper wing surfaces, which often occurs during this operation. However, 4 conventional filling points, 1 for each tank, are provided in event pressure fueling equipment is not available. In addition to the gauge system on the fuel control panel, as well as in the cockpit, an occasional double check of fuel quantity may be made by means of these drip sticks. 1 is installed in each inboard tank and 3 in each outboard tank, so that all fuel levels may be read accurately. Another Electra maintenance safety feature. To facilitate checking engine oil from the ground, quantity gauges are provided along the lower cowling as an optional feature, eliminating the need for any stand or ladder. Replenishing oil when necessary is the only servicing function which requires a stepladder. But one of the advantages of turbine engines is their infrequent need of oil. They do not burn oil in the same sense as a reciprocating engine. During a 1,000-hour flying check on these Allison D13 turboprop engines, which use a synthetic oil known as Turbo 35, it was found that less than 1 pint was used every hour while flying 12 hours a day. This is considerably less than engine spec requirements. With this same outstanding performance, you won't be topping the oil very often. It won't be necessary. While the ground crew proceeds with servicing the lavatories, replenishing the water supply, cleaning the cabin, and attending to other routine servicing functions on this airplane, let's visit an area where we can observe some of the Electra's design refinements and proven efficiencies which have cut maintenance time and costs and are contributing significantly to operating profits. The landing gear incorporates a number of innovations which simplify maintenance procedures. All 3 landing gears retract forward. When extended, they fall free. Mechanical linkage physically blocks actuation of the retract strut while the airplane is on the ground. With this safety feature, there is no need to install downlock pins after each landing, certain to save considerable ground handling time. As soon as the tow bar is attached, the nose gear can swivel freely. This design prevents damage to the nose gear should the mechanic forget to disconnect the scissors, as was former practice with conventional designs. When the tow bar is removed, the nose gear automatically goes back into the steering position. A critical observation of conventional maintenance practices revealed that too much work is done inside cargo compartments, the cockpit, and cabin, soiling the furnishings and creating untimely delays. To eliminate this, Electra equipment and systems were located so that many functions can be accomplished from outside the airplane without the need to remove unrelated units or unload cargo. To provide easy access from the ground, Major related components were grouped within 3 primary service centers located in the lower fuselage. One for air conditioning, immediately aft of the forward cargo compartment. One for electrical, forward of the front wing beam. And one for the hydraulic system, located aft of the wing beam. They are painted white and are well lighted to afford excellent visibility day or night. Here within the hydraulic service center aft of the rear wing beam are selector valves, electrically driven pumps, filters, reservoirs, and other related items including the aileron booster unit. Manifolds are used to mount plug-in type components normally line-mounted. This minimizes any leak potential and permits quick, easy replacement. Considerable weight was saved, and approximately 20 external connections were eliminated by use of these manifolds, so designed that hookups cannot be made incorrectly. Use of electrically driven hydraulic pumps permits checking the system while engines are inoperative and reduces length of lines normally required when pumps are engine mounted. Hydropower is supplied by 2 completely independent systems operating in parallel. In event one fails, the other provides power for priority functions of control boost and flap operations. The dry center section of the wing separates the electrical and hydraulic systems, eliminating any potential fire hazard. Grouped here within the electrical service center are such principal components as propeller controls, generator controls, the transfer relay box, and distribution protection required for this 400-cycle, 208-volt 3-phase AC system, with necessary DC power being obtained through 2 transformer rectifier units. This system can generate 360,000 watts, more than 4 times that in current transports. By placing the air conditioning service center immediately aft of the forward cargo compartment, large units peculiar to this system can be removed through the compartment during overhaul operations. To improve maintainability of the Electra prop and engine, Lockheed adopted many design refinements which provide easy access to critical areas and reduce engine maintenance hours. Numerous propeller functions may be checked with the engine inoperative, feathering, reversing, and practically all of the operational as well as safety features, including the hydraulic system, which is completely integral in both this hollow steel-bladed Aero Products prop and the aluminum alloy Hamilton Standard. Either is available for the Electra power plant. Both are designed to provide rapid troubleshooting and component replacement. A single nut retains the spinner on the Aero Products prop instead of the usual half dozen or so. Turning the nut counterclockwise pulls the spinner off, speeding up the operation and reducing damage to the spinner. Turning it clockwise pushes the spinner on. Since the majority of work on prop jet engines centers around the fuel control and engine accessories, hinged side panels allow easy access to these areas. To further expedite engine handling during removal and installation, a Lockheed-designed lift bar and sling cut the required time for this operation to approximately 2 hours. A hand crank positions the CG and eliminates time-consuming handling adjustments. This complete power package, including the prop, engine, engine-driven accessories, oil system, and cowling, make up the quick engine change unit, which, by the way, is interchangeable among various positions on the Electra by merely changing the different accessories. The Allison D13 engine is comprised of 3 basic sections: the gearbox, compressor, and the hot section, which includes combustion chambers and the turbine gas expansion area. With the engine installed in the airplane, the tailpipe, turbine, and burner can assemblies can be removed to facilitate inspection or for replacement if necessary. This operation provides considerable flexibility. Normally, such inspection is confined to the shop, but with a specially designed Lockheed tool and provisions on the airplane, the turbine and burner can assemblies can be removed on the airplane to determine whether or not the engine overhaul period can be extended, or to confirm or reject suspected damage to this area if engine malfunction were experienced. Incorporation of these design refinements again paved the way toward a high degree of maintainability. Well, it looks as though things are in order for the next Electra flight. So we'd better hurry along and briefly cover some of the other maintenance features before departure time. As you've already seen, accessibility to particular components was designed into the Electra according to the degree of servicing anticipated on those particular units and their systems. In this regard, 4 quick disconnect latches retain the radome, which is hinged at the top for easy access to weather radar and associated units. With the radome open, 4 doors give complete access through the pressure bulkhead to the pedestal area ahead of the instruments, the rudder pedals, and other cockpit controls. Instrument panels are hinged to allow a quick approach to any particular instrument or electrical connection. Access to other flight station items can be made through the nose wheel well, again, keeping as much of the maintenance work as possible outside the airplane. To provide supplemental DC power during flight emergencies or when otherwise needed on the ground, a 36-ampere battery is mounted on a manually operated elevator just aft of the nose wheel well. As we examine each Electra feature, the word accessibility seems to take on new dimensions to give additional meaning, offering unparalleled avenues of approach to inspection and servicing needs. A considerable reduction in dents and normal wear and tear results by hinging the wing leading edges, normally placed on the ground. Note the wiring, ducting, and other units mounted on the front wing beam. Fuel valves mounted here can be replaced quickly because plug-in type components have been used wherever possible on the Electra. In the fuel system in particular, all tank-mounted units, valves, pumps can be replaced without completely draining the tanks. In the event of a fuel boost pump failure, this specially designed Lockheed tool removes the main motor and body of the pump from that fixed portion attached to the tank. One quick turn and the pump is removed for easy replacement after disconnecting the related electrical harness. It is estimated that this plug-in feature alone can save as much as 3 hours maintenance time during a single replacement operation. By the way, all fuel valves are interchangeable, even though some are electrically and some mechanically driven. The only difference being that a motor is attached to one and levers to the other. Speaking of interchangeability, it is interesting to note that in addition to the fuel valves, flaps can be interchanged, left to right and vice versa, as can the main landing gear. Front and aft main cabin doors can be used alternately in the basic airplane configuration. And as was mentioned earlier, all 4 power plants can be repositioned by merely changing different engine-driven components on inboard and outboard engines. Lockheed's engineering staff took considerable care in laying out cables to the various control surfaces for elevator, aileron, and rudder flight control systems. Cables were given space priority with long, straight runs to reduce friction and resultant wear. To eliminate the need for re-rigging and rechecking a complete system every time a component is replaced, idler arms and rigging pins are used. Rigging adjustments in most cases are limited to terminating points in the interest of simplicity and speed. These time-saving steps are going to help shape your operational pattern for profit. Before arriving at the Electra design, a critical analysis was made of the time and procedures required for routine maintenance on today's airline equipment. By comparing differences in basic systems, specific target times were established for hastening the removal and installation of Electra components. Engineering effort was then directed toward a design that would make these targets realistic. The value of this design approach will become more apparent as Electra flights fill the daily schedule of airlines around the globe. Mechanical delays will become more and more a thing of the past because of the foresight and pre-planning that has gone into Electra maintenance features. Well, it looks as though servicing operations are almost completed. Before passengers get aboard, let's take a quick look at the Galley and its servicing provisions. Servicing the Galley through this separate aft door is not only convenient to the Galley's location, but it eliminates any interference with passenger loading, creating less hustle and bustle, allowing both Galley servicing and passenger loading to be accomplished simultaneously. This high tail arrangement affords easy maneuvering and access for both cargo and Galley trucks, with the freedom of antenna obstructions. Flight attendants agree there are many advantages in the various Galley arrangements available in the Electra. Much faster, better service can be rendered your passengers. Access to the anti-collision light mounted on top of the fuselage is made from inside the cabin, allowing the bulb to be changed in a matter of seconds. No longer are ladders or derricks required to reach it from the outside. Notice the width of the aisle in this modern Dreyfus-styled interior. This large aisle and the 4 abreast seating arrangement eliminates a lot of wear and tear on the seats, with the resultant reduction in maintenance costs. The Electra is the first commercial transport to incorporate no-draft ventilation and radiant cabin heating. Extremely low pressure and low velocity air is introduced into the cabin through a continuous outlet grill located below the edge of the hat racks. Radiant heating is provided by low-density electrical elements in the cabin walls and floors, automatically controlled to maintain cabin temperature at the selected level. These wires are embedded in honeycomb covered with fiberglass insulation and vinyl cabin trim. When a panel is removed, the entire assembly comes out as one piece. Radiant heating is but one method used for conditioning cabin air. The other 2 methods used are an air cycle system in combination with a freon or vapor cycle system. Time limits us from going into detail, except to say that the flight station has a separate air conditioning system from the main cabin, using the same source air from cabin superchargers. The freon refrigeration and electrical heating systems eliminate the need for a ground air conditioning truck, since all that is required is that the external power cart be connected and operating to assure comfortable climatic conditions for your passengers while on the ground, regardless of ramp conditions. With a separate cockpit system, crew members can regulate their own heating and cooling requirements without disturbing the temperature in the main cabin. Speaking of external power, you will remember that immediately upon arrival at the ramp, the cart was connected to the Electra before the number 4 engine was shut down, so that electrical power would be available while the plane was on the ground. To start a turbine engine, the compressor and turbine must be rotated to a predetermined speed before fuel ignites in the combustion chambers. The starter, mounted on each engine gearbox, is driven by air pressure to rotate the common shaft connecting the compressor and turbine. Since pneumatic starters have been successfully developed and used by the military for many years, they represent the best experienced method of starting this type engine with an expected trouble-free operation. This start cart, built by Air Research, provides both pneumatic and electrical power. The number 4 engine is usually started first because the 2-speed generator for electrical power is mounted on it. As soon as number 4 is started, the power cart can be disconnected and removed because now the plane's electrical system is operating and ground power is not needed to start the remaining 3 engines. By running number 4 at high ground idle, bleed air can be used to start the second engine. After 2 engines are running, the remaining 2 can be started with the operating engines at low ground idle. This feature provides considerable flexibility during quick en route stops. Portside engines can be shut down while taxiing into the ramp, so that passengers may disembark safely and quickly. As soon as oncoming passengers are on board, operating engines can be used to start the portside ones without the need of maneuvering any ground equipment to the airplane. Such time-saving operations will undoubtedly increase your number of Electra flights per day. One of the optional features of the Electra, which makes it truly a self-supporting transport, is the integral starting system. 2 bottles, charged with high air pressure, are mounted together in the outboard nacelle on each side of the airplane to start the 2 respective engines on that side. These air bottles are recharged in flight by 2 hydraulic-powered air compressors, preparing them for their next use. They may also be charged from a ground source during servicing operations. And so, this is, briefly, the proven maintenance design philosophy which has been built into this versatile airplane to make it the most reliable turbine-age transport in the world, capable of maintaining on-time schedules with short service stops and a minimum of mechanical delays. This fine reputation is a direct reflection of Lockheed's foresight in realizing that serviceability, maintainability, and reliability are among the most critical factors contributing to an airplane's margin of profit. This better than 400-mile-an-hour prop jet is bringing daily turbine travel with an economy of operation, well demonstrated during her pre-service world tour of 19 nations, completed in the fall of '58. Patterned after actual airline procedures, the Electra flew throughout the United States and Canada, across the Atlantic to Europe, operating on tight schedules with up to 6 demonstration flights a day. Continuing across Europe over a wide range of distances and altitudes, in every conceivable kind of weather, the tour covered a total of 52,000 miles, including stops in Asia and the Middle East. Arrival at New Delhi, India for a week's stay afforded the delegates to the International Air Transport Association Convention an opportunity to witness her performance. Many distinguished passengers were among the tour's more than 3,000 airline, government, military, and press representatives who heralded Electra flight and underscored her worldwide acceptance. Though consistently flown under maximum performance conditions, often by unfamiliar pilots, the Electra withstood the rigors of this world tour with an impressive maintenance record despite tough servicing conditions. More than 200 demonstrations were made of her performance with 2 engines intentionally shut down in flight. She hummed along as usual, even with a 3rd engine feathered. It would take more than 5 years airline training operations to equal this rugged test. Her enviable showing of dependability was only surpassed by the persistent feeling of safety experienced by all guest passengers. Because of her scheduled reliability and countless time-saving features, which include multiple servicing operations occurring simultaneously without interference, low, large, well-lighted cargo compartments, underwing single-point fueling, the service center concept, integral stairs, and a self-starting system, your Electra pattern for profit will prove to be a successful one, economically sound. With maximum daily utilization of this airline workhorse, capable of operating in and out of nearly 80% of the world's existing commercial airports, your urgent need for a turbine-age transport, uniquely tailored to operate on the majority of world airline routes, will be filled for years to come.